I see that you're interested in some of the equipment we have in the lab. Let's go check some of it out. Come on. This is a polymerase chain reaction machine, or a PCR machine for short. This machine is used in multiple applications like DNA fingerprinting in forensics or paternity testing. But in my case, I'm going to use it to amplify a section of mutated DNA that could be involved in cancer. Next on our equipment tour is a spectrophotometer. This uses light to measure the concentration of DNA, RNA, and proteins. This allows for experimentation accuracy and consistency. Just like baking a cake, you need to know the right amount of ingredients. Here, I need to know the right amount of DNA in order to use in my experiments. The spectrophotometer is my version of a measuring cup, only smaller. Now it measures the nanograms per microliter, and 1 gram is equal to 1 billion nanograms, or 1 nanogram is 0.000000001 grams. Let's try to imagine that. Say we have an apple. Now an average apple weighs 100 grams, so that's 1/100 billionth of an apple. That's barely an apple. Gel electrophoresis is used to separate and analyze mixed macromolecules like DNA or proteins. DNA, for example, is separated by the size of the gene fragment because different genes have different sizes. First, we make an agarose-based gel to run our samples on. This gel allows for electrical conduction and it is derived from materials found in seaweed. We load samples, such as our PCR products, onto the gel and run them at an appropriate voltage and set a timer. An electrical field moves the charged DNA molecules from the negative end to the positive end. Now that this is set up, it's going to take some time to run, so let's go take a break. Now that this is done, we can image it under UV light, but that's in the darkroom. Would you like to go there next? Welcome to the entrance to the darkroom. Follow me, if you're not afraid of the dark. It's a little dark in here, but just like in a photo lab, we have a red light. The red light isn't very bright, but I brought a flashlight. Scientists also use the darkroom to process images for their experiments. Over here, we have a film processor. This developer processes X-ray films that pick up radioactive and chemiluminescent signals from this special stain along with the DNA. We get images like this. This is a UV transilluminator. It helps visualize DNA, RNA, and protein bands. Let's take a look at our gel from earlier. Welcome to the freezer corridor. It's a little bit loud in here. This is where we store our biological samples like cells or tissues in order to preserve them. On my right I have -80-degree freezers, and on my left I have liquid nitrogen tanks. Now these are both used for long-term storage, but considering that liquid nitrogen's at around -195 degrees, I'm getting really cold, so let's get out of here. We also have -20-degree fridges and a cold room like this one that's kept at 4 degrees Celsius. This is for short-term storage. We also have special storage for chemicals, acids, base, and other flammable materials. Go here. This is a fume hood. It's another piece of common lab equipment. It's very similar to the biosafety cabinet. It's a ventilation device that is designed to limit the person's exposure to chemicals. So, how does it work? Air is drawn away from the opening, up through a filter, where it eventually gets released into the atmosphere. These are centrifuges. This equipment is used to separate liquids, fine particles, and molecules. Centrifuges can spin at very high speeds. This force, combined with gravity, allows the fine particles to separate and sediment to the bottom of the tube. Speeds of a smaller centrifuge can reach up to 20,000 rotations per minute. To help you visualize how fast that is, your washing machine spins between 500 to 2,000 rotations per minute. A car engine at cruising speed spins around 2,000 to 3,000 rotations per minute, and a race car engine reaches up to 15,000 rotations per minute. If we were in a nuclear lab, a zip-type centrifuge can reach up to speeds of 90,000 rotations per minute. Now that is really fast. Whoa, whoa, whoa. Hopefully you didn't get too dizzy, but that's the end of our equipment lab tour. Where would you like to go next?